Hi there, I'm Brendan Burns, Corporate Vice President in Microsoft Azure for Open Source Cloud Native Compute. And I'm here today to talk to you about the state of open source cloud native. I'm really excited to be here and grateful that you've decided that this was worth spending your time. I hope it turns out to be interesting. I wanted to take a step back, to the beginnings of my experience with cloud native open source, which was the sort of precursors to the development of the Kubernetes open source project. And that was in 2012 when I think everybody sort of knew that they wanted to be doing DevOps. DevOps was something that had sort of been out there for a while. There were some meetups and conferences happening, but people were still sort of saying, how do I exactly do this? And the reason that I think that people were saying, how do I actually do this, is because while the ideas behind DevOps had come into being, the tools and technologies that were necessary to actually implement it in practice were either largely missing or hard to use. So companies like Netflix were beginning to sort of set the stage for what DevOps might look like in a tools or a practice-centric view. But really, most everybody sort of had the notion that they wanted to do this, but they weren't really sure how to put it into practice. And I think that that's the origin for the Kubernetes and the cloud native container movement that we saw sort of starting from 2012 and getting to today. And that's really because when people said DevOps, people thought, oh, that means the developer shouldn't be in charge of operations. But it turned out that in practice, without the right kind of tooling and without the right kind of technological adaptations, what it really meant was that the developer is in charge of everything. And it became rapidly clear that actually having a developer in charge of your hardware or having a developer in charge of your operating system was perhaps not the right skill set. And in fact, one of the primary things that Kubernetes thought about doing, and one of the primary things that I think we've seen in the cloud native compute ecosystem, is this idea of specialization, modularity, separation of concerns, so that you can have machine operations be separate from cluster operations and be separate from application operations. This specialization in turn means that actually the people can focus on the specific pieces that they're good at and focus on delivering as a service capabilities, either within a company where you may have a team that is specialized on hardware operations, a team that is specialized on running a Kubernetes cluster, or perhaps more importantly, with the cloud. And it's no surprise, I think, that the rise of Kubernetes and the rise of containers is synonymous with cloud native. And it's not because Kubernetes can only run on the cloud. In fact, many people run it on bare metal environments. I have one in my basement that I use as sort of a test dev lab. But the truth is that it's much easier with this kind of specialization and this modularity to consume things as a service. And so, in fact, part of the revolution that happened in cloud native computing is the fact that when I separate things out, I can actually come to Azure and say, you know what, I want you to take care of Kubernetes updates, Kubernetes deployments, scale out as necessary. I don't want to be in charge of that. And in fact, I'm going to deliver on the promise of DevOps, the idea of DevOps from the beginning, which is that my developers should also be responsible for operating the code that they wrote by taking an as a service for Kubernetes, by using the Azure Kubernetes service and enabling my developers to be focused solely on application operations. And so now here we are in 2022, and I think we've really achieved what DevOps was trying to do a decade before. We've transformed that question mark into an exclamation point, and we have many, many teams who are focused solely on operating their application and delegating to others, and in many cases even forgetting what happens below the layer of their application. I can deliver an SLA to you from the cloud for the Kubernetes API that means that really you don't have to worry much about the details of hardware, the details of operating systems, and focus exclusively on the containers that you're deploying into that environment. So we've achieved the promise of DevOps, I think. And that's pretty fantastic, given that 10 years ago, at the start of all this, it was a question mark. But the truth is, though, that this is kind of portraying a view which says, well, application operation sits on top of a Kubernetes API and any infrastructure anywhere, and really allows you to focus solely on your application. The reality of the situation is that when we talk about building and operating that application, instead of that pretty picture that we had, the picture that we have looks like this. I'm not sure if everybody has seen this before, but this is the sort of mind map of the CNCF that the CNCF themselves put forth, right? This isn't someone sort of trying to write a parody. This isn't someone trying to purposely confuse you, but this is an accurate representation of the cloud native, and in most cases open source ecosystem as it exists today. And depending on the size of the screen that you're looking at this presentation on, you may be able to read a few of these logos. If your screen is like mine and a laptop, you basically can't read any of them. And so obviously the world of cloud native open source is not nearly as pretty as that diagram that I had before. There's a ton of complexity that we've introduced in that separation of concerns, in the modularity that we've developed. And in fact, we've left the question mark and we've moved it from DevOps to cloud native. And I would say that the state of cloud native open source right now is a little bit confused and needing someone to act as sort of a guide and needing people to actually help them put these pieces together in a way that delivering their application on top of the Kubernetes and container APIs makes sense, right? And so one of the things I'd like to say is that if we've spent 10 years building the tools and technology necessary to go from DevOps being a question mark to DevOps being an exclamation point, I strongly suspect that we're going to spend the next 10 years taking cloud native from being a question mark to cloud native being an exclamation point. And in 2032, assuming I get a chance to come back and talk to this conference again, I'm hoping that there'll be something else that's confusing us, but that we'll be able to say, you know what, we actually did really manage to nail that cloud native thing. And so I want to spend the rest of the time talking about what Azure is thinking about. I don't think, we're not the only ones with a job to do to help explain and help make usable cloud native computing to the world. But Azure, I think, is in a very unique position. Microsoft has a tremendous history in developer and developer productivity. And so we have a real opportunity, I think, to help focus the discussion, help simplify those diagrams, and truly deliver on the promise of cloud native, just like we've helped deliver on the promise of DevOps over the last 10 years. So I'm going to spend the rest of the time talking about how Microsoft and how Azure thinks about taking this developer who is going from a question mark, trying to figure out how they get their application onto the server, and how they can become a productive developer on top of the Kubernetes API. And then I think a special concern that I've been thinking about a lot lately, and many other people are, and is near and dear, obviously, to anyone's heart who's working in the cloud, is how can we help developers be more productive, but also do it in a secure way? Because these new technologies have created new attack vectors, have obfuscated old habits that we had learned. I've always said it's kind of amazing how, by changing from a web browser to the Docker command line, suddenly it became okay to download and run things off the internet, supplied by random strangers with GitHub handles that don't necessarily make even sense. Obviously, that's a bad idea. You should not be running images just straight off the internet without checking where they're coming from. But new technology has a way of obfuscating old habits and old security patterns that we've designed. And I think there's a lot of effort that needs to go into the cloud native community to make sure that even as we share and even as we come together as a community, we're doing it in a secure way. I'm going to start out by talking about that intersection of security and developer, right? And it seems maybe a little bit of an odd thing to start with a relatively small feature. This is the Kubernetes extension that we've built for VS Code. VS Code is literally the most popular development environment for cloud native development by a large margin. It seems obvious that we should build good integration into Kubernetes. We've built this integration. You can see a little bit on the left, but I wanted to highlight what happens when you right-click on a pod. When you right-click on a pod, you get a lot of different capabilities that you can do with that pod. And one of those capabilities is port forward. Why is this important? Well, it's important for two reasons. One is no one had to help you discover how to do this, right? Since the dawn of time, you've been told that if you right-click on something, you get an interesting set of options that you can use with that thing. And so if you're visualizing your application and wondering, how do I connect to that application? You go hover over it, you right-click, you see port forward, you're connected to your application. It's going through the Kubernetes API server, it's going through all of your authentication, and it's secure. And you've done it, you've sort of accidentally fallen into the secure best practices path. Because if we hadn't built these sorts of things in, the easiest way for you to, gain access to your application might be to just kick it up on the public internet. And if you do that to an application that really wasn't built for being secured on the public internet, or you don't really think about the fact that when you put it on anything on the public internet, within a handful of seconds, and I'm not even joking about this, within a handful of seconds, it's been scanned by someone with malicious intent. Well, if you're not careful about that and you don't use something like port forwarding, this is what happens to you. Right? It's 2021 and crypto mining is the thing. And so if you're not using the tools in the right way, you're going to get crypto mined or you're going to get attacked in some other way. But the thing is, you can't expect developers to just do the right thing by default. You have to help them fall into that pit of success. And so I think as we think about security, as we think about developer productivity in a cloud native environment, we can't expect everyone to memorize that eye chart of the CNCF diagram. We have to build these paths that are natively incorporated and provide best practices in security by default and by easiest, not just by default, but by the easiest way, so people will fall into those paths. In a similar light, I want to talk a little bit about policy. I think everybody's familiar with using RBAC, role-based access control, to secure their Kubernetes cluster. But access control leaves a lot of open questions, like from things as simple as like, where did you get that image from? Are you pulling it from Docker Hub? Or are you actually using a private registry? All the way through to like, who's the contact information? If I find out that there's a security problem with your service, how do I make sure I let you know about it? Or even, did you get a security review before putting something out on the public internet? These are all critical questions that you want a developer to answer before they put them out there. And they're only answered via policy. And so I think one of the most important shifts that we saw in the Kubernetes ecosystem was the introduction of things like policy, and customers who are coming to us and saying, hey, how can I possibly ensure that my developers can move quickly, that they can push code all the time, but at the same time, my CISO can sleep at night knowing that they're not going to have pulled in random images off of the internet that could change or add crypto mining or any other sort of vulnerability to my services. I think one of the great things that we can do as Azure is take that intersection of the sort of more legacy or enterprise concerns of things like policy, as well as the more cloud native and digital native concerns of pushing code quickly, and marry them together. And in fact, we did this with the Gatekeeper project. We created an open source project called Gatekeeper, donated it to the CNCF, and it is now sort of the de facto way to do policy within Kubernetes. And I think it's a great example of how experience in the market and talking to our customers leads us to open source innovation. And in fact, actually a large community in the cloud native community that has come together around Gatekeeper. So again, trying to build tools and technologies that enable that developer to simply fall into a secure path, fall into a safe path without getting in their way or without forcing them to learn a lot of things. Another great example of this is, if we've talked about building new open source projects, I think another really important thing that we can do as Azure in the cloud native ecosystem is integrate our own products with the cloud native ecosystem. This is an example from Active Directory, where we had this idea of privileged access management, where by default you can have a group that has access to your Kubernetes cluster, but that nobody is actually a member of. If you need access to it, in the case of a live site, in case of an emergency, you can request access. You can send an email to someone and request being elevated into that group. You get temporarily added into this membership group. You can access your Kubernetes production infrastructure. And then after a certain amount of time, you're removed. This is, I think, it's one thing to create whole new open source projects, but if we don't take the identity systems that we already have and build the integrations with existing open source projects so that all these capabilities that have been built into Active Directory, if we don't make those things available to people who are choosing to use, whether it's Postgres or Kubernetes or whatever the favorite open source software is, we're really doing a disservice. So at Microsoft and Azure, we're focused not just on creating innovation in the open, but actually integrating our own products with open technologies as well. And so when we look at GitHub, when we look at VS Code, we're targeting any Kubernetes anywhere, and obviously ensuring that the best practices that we've encoded in those products are available to users no matter where they want to access that open source software. And then finally, I think there's a third part of what it means to be a good citizen in the cloud native ecosystem, and that's helping other projects, right? So we looked at this other problem that our customers had, which was how do you scale up DevOps? Obviously, the more clusters you have, the more configurations you have, you're going to run into problems. You're going to have copies of those configurations everywhere. They'll have skew. They get out of sync with one another. The pattern that's emerging out in the world is this idea of GitOps. Now, GitOps is the idea that you have one copy, it's in a Git repository, could be GitHub, could be anything else, and there's a great open source project already called Flux. And rather than building a whole new version of GitOps that was tied into GitHub or was tied into Azure, we went to the Flux community and said, hey, we want to participate. We don't want to just take your software and run it. We want to actually participate with you, help move GitOps forward as the way that the industry operates at scale, and actually contribute to your project. And so in addition to building our own projects, integrating Microsoft products with open source, we've also come and contributed to existing projects when it makes sense to help them grow and help them become, the solution that people use. I wanted to finish with another piece of open source that we think is really important, and that's innovation, helping people do a better job building applications. And so the Dapper project is a new project. It's reaching a production usage, but sort of trying to drive the industry forward by being a standard library for Kubernetes. If containers are the runtime for Kubernetes, Dapper is the standard library. And it follows the typical sort of sidecar pattern of a user application with that Dapper co-process. This gives you an example of just how easy Dapper makes it to store something. It's just a simple post to localhost. No authentication necessary, no encryption necessary. All of that is handled by that Dapper sidecar. Kind of familiar if you're used to a service mesh, but you can think of it as accomplishing much of what the service mesh is doing, but actually also trying to make your programming easier also. And the other important piece of this is that you can use it with any existing application. It doesn't require you to adopt a framework like a PaaS would, like a serverless paradigm would. Dapper can be used alongside any traditional application you already had, any language, and a bunch of different components from storage to secrets to events and authentication. We really want, in the spirit of open source and innovation, we really want you to come join us. Dapper.io will give you more details, or github.com/dapper/dapper. Thank you so much for taking the time to spend with me to talk about cloud native and open source and Microsoft and Azure's contributions to those communities.